Okay, now we're ready for section 4-4, solving polynomial functions by factoring. The basics of factoring for for standard form quadratic equations when they're in standard form, which is ax squared plus bx plus c. If you can remember that c is the product of the two factors and b is the sum of the two factors, then you will be just fine doing factoring. So for example, if I give you x squared plus 7x plus 12, I'm asking what two numbers multiply to 12 and the same two numbers that add up to 7. So this is always a sum, this is always a product. It is imperative that you start with factors of this number. So if you find numbers that add up to 7, that's great, but if they don't multiply to 12, they're kind of useless to you. So if you get really stuck and you can't see it, I want you to list out your factors of 12. So for 12 you have 1 and 12, 2 and 6, and 3 and 4. So now you know that those are all the factors, and all you have to do is look and see which pair have a sum of that middle term. And in this case, it is 3 and 4. So 3 times 4 equals 12, 3 plus 4 equals 7. So when you write those factors out, you would have x plus 3 and x plus 4. And now knowing what we know with our different methods of multiplying, we can check that. So I'm just going to check it real quick with box method. And I have x plus 3 and x 4. So I get x squared, 3x, 4x, and 12. And if I combine those two middle terms, I have x squared plus 7x plus 12. Okay. The first ones we're going to do are pretty basic factoring, pretty simple. Remember to be careful with your signs. Signs make a difference. If this last product, so if C is positive, then the factors can either be positive, positive, or negative, negative. Because if I multiply a positive by a positive, I get a positive. If I multiply a negative times a negative, I get a positive. If C is negative, you're going to have one of each. Okay, so that's kind of an important guide to remember because the signs make a difference. They definitely make a difference. Okay, so let's go through and factor each one of these real quick. I'm going to start with my factors of 15, but I also know that my middle term is negative, which means that both of my terms need to be negative. A negative times a negative gives me a positive. A negative plus a negative gives me a negative, so I'm okay. And I know my factors of 15 are 1 and 15 and 3 and 5. So the only two terms that add up to 8 would be 3 and 5. So my factors are x minus 8 and x minus 3 and x minus 5. Okay. For number 2, my factors for 16 are 1, 16, 2 and 8, 4 and 4. The pair that has a sum of 8 would be this. So you would have x plus 4 and x plus 4. The other way that can be written is x plus 4 squared. And that's going to come into play when we multiply and when we're asking how many solutions that has. Because that's technically only one real solution. So I want you to kind of keep that one in mind. Okay. Now, 10 is a negative number. So the only way I can get a negative as a product of two numbers is if I multiply a positive times a negative. So, and now I need to think about my factors of 10. So I have 10. So to get negative 10, I would have 10 times negative 1, negative 10 times positive 1, or 2 times negative 5, or negative 2 times 5. And I'm still looking for a sum of negative 9. So the only one that has a sum of negative 9 would be negative 10 and positive 1. What you need to remember is when you find this, whatever sign goes with that b term, if b term is negative, whatever your larger factor is going to follow that same sign. So I had a factor of 1 and 10. 10 is larger than 1, and so that negative is going to go with the 10 and not with the 1. It's kind of a little trick. Okay, last one. I have positive 6, but my middle term is negative, which means both of my terms need to be negative. A negative times a negative again is a positive. Negative plus a negative is a negative. So my only options are 1 and 6 and 3 and 2, and those are all negative. and the only one that totals -5 would be -3 and -2. Some of you might be asking, why are you not worrying about the x in this phi? Well, I always know that if I have something simple like an x squared, x times x is the only way I can get x squared. So I kind of leave it as a afterthought after a while. Okay, but what if that a value is not 1? So far all of these have been easy. All of these a values are 1, right? The only thing I can multiply to get x squared is 1x times 1x. But of course we know that that's not always going to be the case. We have many, many times where that coefficient of a is not a 1. Sorry, I had a little technical glitch. So continuing on. So we know that there's many cases where our quadratic equations do not have an a value of 1. They were nice and clean up here. They were easy. But for like in this case, we have an a value of 2. Well, what do we do then? So there's two different methods that you can use. When I learned how to do factoring in high school, there was one way, and it was guess and check. And it was very time consuming, and especially when you had large numbers with lots of factors, or when you had negative numbers, it was extremely time consuming and annoying. So these two methods are short, sweet, to the point, literally 3 steps, and there's no guessing and checking involved. You're actually just figuring it out. So I'm going to show you both ways. It's up to you, again, to choose which way you're good at and make sure you're really good at it. Okay, so BFD stands for borrow, factor, divide, and simplify. Easy, right? All 4 of those sound doable. Okay, so let's start with our equation, 2x squared plus 17x plus 21. And then I'm going to borrow my a value and multiply it by my c value. So that will make my a value now come back to 1 and make it easier to factor like the ones we had up above. So 2 times 21 is 42. Now you're going to factor that. Okay, and so the factors of 42 are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. In class, I'm going to show you a trick of how to figure out your factors easily, especially when you've got large numbers going on. Okay, so the only two that add up to 17 would be 3 and 14. So there's my factors. Now, whenever you borrow something, you need to give it back. So the way I'm going to undo that borrowing a or multiplying by a is I'm going to divide by my a function. So I'm going to divide each of my factors by 2. So now here's where the simplifying part comes in, and this is an important step. Say, for example, my factor here had been 6 over 4. So say I'd had 6 over 4. Well, that's not completely simplified, is it? And it needs to be. You cannot go to this next step until you have that simplified. And when I say simplified, I don't mean rewritten as a mixed number, like 1 1/2. I mean just in improper fraction, but reduced as far as it can be. So 3/2 is okay. It's reduced. We're fine. Okay, so let's do this one first. If it reduces to a whole number, so for example, 14 divided by 2 is just 7, then you reduce it and you're done. That's one of your factors. If it does not, then this denominator is going to swing out to the front, and this will become 2x plus 3. And those are your factors. Let's go ahead and multiply it. I'm just going to do it by vertical method just to double check that when I multiply these two factors together, I'm getting what I started with up here. Factoring is really just a algebraic word for dividing. It's really what you're doing. Okay, so 3 times 7 is 21, 7 times 2x is 14x, 3 times x is 3x, and 2x times x squared, or times x is 2x squared. So I get 2x squared plus 17x plus 21, which is what we started with up here. Okay, so the other method I'm going to show you is something that I call X factor. I think Mr. Rowe calls it star method. You can call it whatever you want as long as you can do it correctly. So I'm going to start with that same function. And here's what you're going to do. You're going to draw, this is why I call it X factor. You're going to draw an X, and then you're going to put a line in between. Okay? On top of that line, you're going to put your A value and the variable. So A value and the variable on top of both of those. Okay? Then in this area up here, you're going to put your A times C value. So A times C in this case is 42. And in the bottom, you're going to put your b value. Now, depending on who teaches it to you, that AC and B might be flipped. It's really irrelevant as long as you remember which one is a product and which one is a sum. So now I'm going to factor 42 into two numbers that also add up to 17. So this is a sum, this is a product. Go back to the beginning of our notes and remember what we're always trying to get to with factoring. So I know that the factors of 42 that add up to 17 are 14 and 3. Now at this point, now you need to simplify. Now if you simplify to a 1, you need to keep that 1 in there. So this would simplify to 1 over 7. This one doesn't simplify, we're going to keep it just as is. Now what happens is your numerator becomes the front of your binomial, the denominator the back. So this is 1x plus 7, and this one is 2x plus 3, which happen to be the same terms that I got over here. Doing BFDs, get the same answer, two different methods. I'll leave it up to you to decide which way you're going to do that. Okay, they're both equally easy, I think. Okay, so that's factoring. Let's see. Okay, factor by grouping. So this is not something I use a whole lot, but some really understand how to do factor by grouping, and it has some good uses. So I am going to go ahead and teach it to you. So in order to factor by grouping, you actually need to separate your terms into groups that have a common factor. So before you can do that, the middle term is the one that's going to cause you issue. So if I just look at that, I don't see anything in common between any of those terms. Okay, but if I think about what, and you're kind of using that AC value again, what two numbers can I multiply together to get, when I multiply 1 times 15, I get 15. And I want to think about those factors. So then I'm going to say, oh, I can split 8x into 3x plus 5x. So this is an equivalent expression to this, just written in a different way. Now I can factor by grouping. So the common factor I have between x squared and 3x would be an x. And once I factor that out, I have x plus 3. The common factor I have between 5x and 15 is a 5. And if I factor that out, 5x divided by 5 is x, 15 divided by 5 is 3. This becomes my common factor that I have. So that is one of my factors. The other factor is what I have left, and I write that together, and I get x plus 5. Okay? And if I check that, I know that to be right. 3 plus 5 is 8. 3 times 5 is 15. Okay? It does work with these two. So you still need to do that same thing. I need to figure out, okay, if I multiply 5 times negative 15, I get negative 75. So what numbers can I multiply together to get negative 75? Well, I've got 75 and 1. I've got 25 and 3 multiplied to 75. So I could either do negative 25 and 3 or 25 and negative 3. And actually, no matter which one of those you choose, you'll be able to factor it. So 5x squared I'm going to use 25x and negative 3x. Oh, wait a minute. Can I do that? Now check what happened here. Does that add up to negative 22? They don't, right? So actually my signs need to be reversed. So this is not an option for me. You've got to make sure that those signs are going to behave the way you need them to behave. Okay, so negative 25x plus 3x does give me negative 22. And that gives me negative 15. So now I can factor. So now if I factor by grouping, you're just separating them into two sets of binomials. So out of 5x squared and 25x, I can take out a 5x. Once I take that out, I have x left, and then negative 25x divided by 5x is negative 5. Then out of 3x and negative 15, I can take out a 3. And once I divide 3 from each of these, 3x divided by 3 is x, negative 15 divided by 3 is negative 5. And lo and behold, I have the same factor for both. So that becomes one of my factors. And then the other factor is going to be what I factored out of each put together. So my other factor will be 5x plus 3. Again, I would check it to be sure that this is actually correct. So I'm going to use vertical is my preferred method of multiplying. You can choose whatever you want. But right, and x minus 5, so that gives me negative 15, negative 25x, 3x, and 5x squared. And when I total this up, I get 5x squared minus 22x minus 15, and that checks out. So now we've done all this factoring, and for what? What are we using it for? Well, the real reason you're actually using it is so you can actually solve that equation. If you've got a polynomial equation, they're a little bit more complicated than just a regular linear equation, aren't they? So once you have your factors, whenever you are solving a polynomial equation, you always want to set that equation equal to 0. Always, always, always. So if it's not set equal to 0, then you need to do that first. So in this example, we have x squared minus 5x equals negative 6. I need to move that negative 6 to the other side. I'm going to do that by adding it. So now I have x squared minus 5x plus 6 equals 0. Now you're going to factor, and you'll have x minus 3 and x minus 2. Then you set each equal to 0 and solve. Okay? So you're going to have x minus 3 equals 0 and x minus 2 equals 0. The more you do these, you're going to see that there's something that happens. So if I have to add 3 to both sides, and I get x equals 3 as one of my answers, and I add 2 to both sides, and I get x equals 2 for my other answer. Your solution is the opposite of the factors. Okay, always. All right, let's go down and do example 4. So we have 8x squared plus 18x. I'm going to have to move that 5 over to the other side, so it's going to become negative 5 equals 0. And I'm going to, what am I going to do? I'm going to try factor by grouping, because I don't really use that one very much, so I'm going to try that. So 8x squared minus 5. My AC value is negative 40, so I've got to get something that multiplies to negative 40 that adds up to 18. So I've got 20x minus 2x. So that should work out. Because 20 minus 2 is 18. And 20 times negative 2 is negative 40, which is my AC value. So I should be okay. So let's see what happens here. So out of 8x squared, I can take out a 4 and an x. And then I'm left with 2x plus 5. Sorry about that. And then since I already have a 2x minus 5, that's okay, but I need to take something out, and my signs aren't matching. So I'm going to take out a negative 1 out of the negative 2x minus 5, and then I'm left with the same factor. So one of my factors is going to be 2x plus 5. The other factor is going to be 4x minus 1. Each of those I need to set equal to 0 and solve. And what ends up happening is it ends up being the opposite of this constant divided by that coefficient in front of x. So here I would have 2x minus 5, or sorry, 2x equals negative 5. And then I divide by 2, so my x would be negative 5 halves, and that works out. The opposite of 5 is negative 5 divided by 2. That's one of my solutions. And then 4x equals 1. I have to divide each side by 4, so x equals 1/4. And if I check that, the opposite of negative 1 is 1, divided by 4 is 1/4. Okay? All right, that's the end of 4.4. 4.5 and 4.6 will be coming shortly. Thanks.